Okay, so we're going to start with representing the real world, which is the vector data and raster data. So, representing the real world, we will start with the vector data first. So, how would you create an information system to organize and manage the huge variety of geographic stuff in the world? So, one approach is to think of all that stuff in terms of discrete objects. So, the discrete objects view of the world. If you conceive of geography in terms of objects, we can sort these objects by similarities. Shape is a fundamental sorting principle. Every object can be drawn in two dimensions as either a point, a line, or a polygon, thing, or type. In another principle, every object can be classified as a school, a road, a park, or something else. Applying the sorting principles of shape and thing, we can come up with collections of things you would recognize on a map. Schools represented as points, roads represented as lines, parks represented as polygons, and so on. So each object in a collection has a unique location specified by a pair of spatial coordinates for point or a list of coordinates. Alright, let's back up. Okay, points, lines, and polygon. So, points, lines, and polygon representing geographic objects on a map. So, a polygon with an X indicating its centroid, and the list of coordinates pairs that define its location. Besides a unique location, every object has a set of facts that pertain to it, a name, a description, or whatever bits of information have been gathered about it. These facts are the object attributes. So in ArcGIS, a collection of such objects with a common shape, common thing, and common attributes is called a feature class. So an individual object in the collection is a feature. The feature class is the basic storage unit for GIS data created according to the discrete object view of the world, commonly called the vector data model. So feature classes can be stored in various file formats, notably the geodatabase and the shapefile. The geodatabase format is newer and more highly developed. And the continuous surface view of the world. Although it is a powerful model, the discrete object view is not an intuitive way to think of certain kinds of geographic information, such as elevation or temperature. So they don't have shapes or boundaries, and that covers the world everywhere. So it's quite possible to represent these phenomena as features. For example, contour lines represent elevation on topographic maps, but a more natural way to think of them is in terms of continuous expanses or surfaces. So the most common way to model a geographic subject surface is with a matrix of square cells or pixels. Each cell represents a unit of area, such as a square meter, and stores a single piece of geographic information, typically a measured or estimated value at that location. So in this example, each cell represents 30 square meters of ground and stores a single representative elevation value. And this way of modeling surfaces is called the raster data model. So it is commonly used for elevation and its variations, slope, aspect, for temperature, precipitation, and land cover, for statistical data such as densities and means, and especially for imagery. The raster dataset is the basic storage unit for GIS data created according to the continuous surface views of the world. Raster datasets can be stored in geodatabases or in various standard image file formats such as TIFF and JPEG. Feature classes in raster datasets are complementary in many maps. Raster datasets are used for background display, whereas feature classes are used for foreground display and analysis. Okay, so those are the very basic representation form for GIS, and we have to understand that. Okay, so the raster data and the advantage for raster data, you can calculate disadvantage. So we will go over. So the advantage of raster data, so it's a great format and model satellite and remote sensing data for raster position. It is simple to understand the cell size. Map algebra with raster data is usually quick and easy to perform. Overall, the quantitative analysis is intuitive with discrete or continuous rasters. So the disadvantages here, the cell size contributes to geographic quality. It can be a pixelated look and feel. So to illustrate, the linear feature and path are difficult to display. You cannot create network datasets or perform topology rules or rasters. Also, we don't have the ability with raster data attribute table. Raster datasets can become potentially very large because they record values of each cell in an image. So as resolution increases, the cell size decreases, but it comes at a cost for speed of processing and data storage. So vector and raster spatial data types. So we do not want to work with pixel or coordinates. Raster data works with pixel. Vector data consists of coordinates. So the map scale, vector data scale objects up to the size of the billboard, but we don't get the type of flexibility with raster data. So the restriction for file size, raster file size cannot result larger in comparison with vector data sets with the same phenomenon and area. Okay, back here. And we will preview the puzzle data, which comes from the county of Los Angeles. Switch the imagery with label base map using the base map button on the map tab. So, which I did. We have world imagery with the label. I don't know. Maybe let's double make sure. All right. Okay. So that's the one. And in the project pane under City of Los Angeles folder, we will go to puzzle shapefile to highlight it. Okay. City of Los Angeles, yeah. Don't crash. Okay, City of Los Angeles. We highlight the icon. Puzzles, right here. Okay. And right click on the puzzle, we will go to View Metadata. So a new project tab is display and shows metadata or data documentation, which is right here. Let me drag in the middle. So So what we see here is the details and overview of the dataset. Complete metadata includes a description about the data, when and how it was created, attribute information, and so on. So acquiring the data. So in any GIS project, acquiring good data is a big part. It is a big part of the job. So ArcGIS Online provides datasets representing many types of geography. We can access this data from a web browser or directly from ArcGIS Pro by switching from the Project tab on the Project pane to the Portal tab. We can search for particular types of data by keywords. We can also search for ArcGIS Online groups such as Living Atlas that curate a variety of authoritative content. So for spatial data, we can use ArcGIS Open Data. Open source software spatial data is also widely available. from government agencies, educational institutions, and commercial vendors. All these sources may supplement data collected and managed by the own organization. So we're gonna scroll down through the detail. From the top, we see the data name, the city of Los Angeles puzzles, and a file type shapefile, a thumbnail image, text that make the data searchable, a summary of the intended use of the data, a description of the data content, credits, attributing where the data come from, use limitations related to the license agreement, extent of the dataset in latitude and longitude, scale range of the dataset from maximum or minimum. And we will switch from the details view to the preview view in the lower left corner of the puzzle. So detail and then preview is right here. So now the preview. This view allows a visual inspection of the data. The view can be panned and zoomed to close the project view tab and currently display the metadata. Very cool. And the puzzle shapefile to the here is the map. Will zoom to the extent of shapefile. So we will zoom until we can easily distinguish features. So gonna zoom in, not here. So we can see those land puzzle. When you buy a house, then this land is yours. So that's very cool. So this is the spatial data we need and showing individual puzzle boundaries. With the Explore 2 enabled on the Map tab, we click any puzzle to identify it. For example, I'm gonna go back home. Oopsies. So I have my folders here. Go back to map. I have to edit that layer first. Alright. Okay, puzzles data. Zoom to layer. Okay. Oh, okay. Those are the areas that have houses. For example, houses here, residential. Okay. And we click any puzzle to identify it. The result will be displayed in a pop-up window showing all the attribute of the feature. So now we depending on the exactly where we click. And let me change a little bit. Property. Let's do this time do pink. Do 2 and no color. Click apply. So we can know some of the houses and identify them. The number of identified features will be displayed on the lower left of the pop-up window. We can use the arrow buttons at the bottom to move through the features. The vacancy attribute we need isn't here, but we do not have an area attribute in unspecified units. Once we find out what the units are, which we will do later, and we can convert them to acres. And the figure provides some visual contents for the size of a 1/4 acre puzzle compared with a 5-acre park. And now we're going to close the window.